Hi, this is John Linneball from John Linneball Tutoring, and this is Barron's SAT Premium Study Guide, Chapter 60, Ratios and Proportions. The first problem is problem 1 on page 493. If 2/3 of the workers in an office are non-smokers, what's the ratio of non-smokers to smokers? Well, since 2/3 of them don't smoke, that means 1/3 of them must actually be smokers. So therefore, there are going to be 2 non-smokers for every smoker because there are 2 of every 3 workers in the office don't smoke. So the ratio of non-smokers to smokers is 2 to 1, 2/3 to 1/3, which is choice B. Problem 2, page 493. If 80% of the applicants to a program were rejected, what is the ratio of the number accepted to the number rejected? Well, if 80% were rejected, then 20% were accepted. We know 80% is 4/5, 20% is 1/5. So 4/5 were rejected and 1/5 were accepted. So the ratio of accepted to rejected applicants is going to be 1/5 over 4/5, which just becomes 1/4 when we simplify it. So that's choice B. Problem 3, page 493. The measures of the 3 angles in a triangle are in the ratio of 1 to 1 to 2. Which of the following must be true? The triangle is isosceles, the triangle is a right triangle, or the triangle is equilateral. So it's always a good idea to draw a diagram. Well, we're going to have to try to draw it proportionally. So we can just take the 1 to 1 to 2 ratio and just write x after each one of them, or just write x instead of 1. So we're going to get x to 2x, and then write the equation x plus 2x is 180. So 4x equals 180, and x is 45. So the angles are 45, 45, 90. And how do I know that? Well, because we know it's going to be x, 2x. So that's 45, that's 90. So we draw a right triangle with 2 equal sides. How do we know they have 2 equal sides? Because they're 2 equal angles, and therefore the sides opposite these angles also have to be equal. It's the definition of an isosceles triangle. So that tells us that number 1 is true. The triangle is definitely isosceles. Number 2, it's a right triangle. Why? Because we know one of the angles is 90 degrees. We figured it out algebraically. The triangle is equilateral. Well, no, that can't possibly be true, because if it's equilateral, it's also equiangular, which means these 3 would all have to be the same. So they have to be a little notch in this one as well, a little line through it. And this would have to be 60, this would be 60, this would be 60, because all the angles would have to be the same. So it'd be 180 over 3, which is 60. Since that's not true, 3 is false, so it has to be answer D, 1 and 2 only. Problem 4. What is the ratio of the circumference of a circle to its radius? Well, the circumference is c equals 2 pi r. The ratio to the of the circumference to the radius is 2 pi r over r, because you can see c is 2 pi r. There's an r under it. The r's on the top and the bottom cancel out, and you end up with 2 pi, which is choice D. Problem 5. Page 493. If a to b is 3 to 5 and a to c is 5 to 7, what's the value of b to c? Now, an economist might joke with you, say, well, the value is whatever people will pay for it, so the value of b to c must be whatever people will pay for b to c. Ha ha ha. Anyway, since we know the ratio of a to b is equal to 3 to 5 and a to c is 5 to 7, we can quickly figure out that the ratio of b to a is 5 to 3. We just flip 3 to 5 over to get b to a. So then all you have to do is line them up like they're fractions. So you go b over a times a over c. You can see these a's cancel out, and that's what you do. So since a over c is 5 to 7, b over a is 5 to 3, you just multiply b over a times a over c, which is 5/3 times 5/7. I had it in the wrong order here, but it doesn't matter, the commutative properties. Anyway, b over a is 5 over 3, a over c is 5 over 7. You can just multiply them to get 25 over 21, or 25:21, which would be the answer listed there. So, alternately, you can find a common value for a in both ratios. And again, you can treat them like you're finding the common denominator for a fraction, where you just take b over a is equal to 5 over 3. You multiply it by 5 over 5 to get 25 over 15. Why do you do that? Well, because a is 5 in the fraction, or the ratio, I should say, in the ratio a to c. So you're going to need a common multiple of 5 and 3, and since they're both prime numbers, you just are going to have to multiply 5 times 3. So you multiply 5 over 7 times 3 over 3, you get 15 over 21. So then the ratio of b to a to c is going to be 25 to 15 to 21 And so you can just take the A out and you'll get the ratio of B to C is 25 to 21. It's a little more convoluted, but if you're not confident in the first approach, by all means, use the second approach. There's no wrong way to do this other than one that doesn't give you the right answer consistently, okay? Problem 6, page 493. In the diagram, B to A is 7 to 2. What's B minus A? So I did a very crude redrawing of the drawing in the book. You have a straight line. You have two angles that add up to a straight line. B and A. We know that B is bigger than A, and it tells you the ratio of B to A is 7 to 2, so B is 7x, A is 2x. So 7x plus 2x is 180. It adds up to a straight line, so it's 180 degrees. So therefore 9x is 180, x is 20. So B is going to be, that shouldn't be B minus 7 times 20, sorry, it should be B equals 7 times 20. So B is 7 times 20 equals 140, and A is 2 times 20, which is equal to 40. So B minus A is 140 minus 40, which is 100, which is choice C. Problem 7, page 493. If x is a positive number and x over 3 equals 12 over x, what's the value of x? All right, so, excuse me, the easiest way to do this is just to cross multiply. We see x over 3 equals 12 over x. We multiply it, we get x squared over 3 equals, well, okay, we're going to multiply the x's, we get x squared, multiply 3 times 12, we get 36. X squared equals 36. So x is equal to 6. Remember, they say x is positive, so it can't be negative 6. So that's choice C. Pretty easy, right? All right, problem 8, page 493. A snail can move I inches in m minutes. At this rate, how many feet can it move in h hours? Well, the speed of the snail is going to be I inches over m minutes, or I inches per minute if you like. 1 foot is 12 inches, and there are 60 minutes in 1 hour. Hopefully you know that, but in case you don't, you do now. And they will give that to you on the test, actually, especially English measurements, because could be somebody who's from almost anywhere else in the world that uses the metric system rather than the English measurement system. But getting back to this. A snail's speed in feet per hour is going to be I inches over m minutes times 60 minutes per hour. So you can see that minutes cancel out right there. So it's going to be times 1 foot over 12 inches. So you see inches also cancel out. So it's going to be 60 I feet over 12 m hour, or hours. Doesn't matter whether you say feet or foot in this problem. They're just placeholders so you know what's going on and so the units work out right. Remember, if the units don't work out right, it means you made a mistake and you need to go back and check your work. So, okay, 60 times I times foot over 12 times m times hour. 60 divided by 12, hopefully you know that's 5. If you don't, use your calculator. If not, then fine, you're going to have to do it by hand on the test booklet if it's on the non-calculator section. That's why you should make sure you know how to factor, because then you can quickly say, oh, okay, 60 is 12 times 5, so boom. That cancels out to 5. So we get 5I feet per hour. Since the snail moves for h hours, the distance the snail moves in feet per h hours is going to, or in h hours it should say, is going to be 5I times foot times m over hour times h. So that's going to be equal to 5hi over m feet total in 5 hours. That's choice A. Problem 9, page 493. Barbara can grade T tests in 1 over x hours. At this rate, how many tests can she grade in x hours? Notice they're using confusing variables, etc. So we can see they're using confusing variables, and we're going to get past that. How? By being very careful. So just as the distance equals the rate times the time, work can equal rate times time. So if you're driving a car at 60 miles an hour, you know it takes an hour to get 60 miles. Well, if you are doing a job, you can divide the job by the time to get the rate. You can divide the job by the rate to get the time, etc. So T tests in 1 over x hours equals R. So R is equal to T tests over 1 hour divided by X, which is equal to TX tests per hour. So that's the rate, is Barbara grades TX tests per hour. So in X hours at the same rate, the work is going to be X hours times tx tests per hour, which is equal to tx squared tests. That's choice B. Problem number 10. Page 494. If 500 pounds of mush will feed 20 pigs for a week, for how many days will 200 pounds of mush feed 14 pigs? First, you want to set up the problem. We know the ratio has to remain the same. We can assume that all the pigs eat at the same rate, even though we know that's not necessarily true. So, if you have 20 pigs in 7 days that eat 500 pounds, we can set that up as one ratio. So it's 20 pigs times 7 days over 500 pounds. And then we have 14 pigs times D days over 200 pounds, because we don't know how many days the food's going to last, so it's just D. So now we solve for D. So 20 pigs is, notice the pigs cancel out because there's 14 pigs on the bottom. And then times 7 days, well, we can see that the days cancels out on the bottom. And over 200 pounds, well, we can see the pounds cancels out because there's a pounds on the bottom. So you just end up with 20, well, you end up with 20 times 7 times 200, which is the same as 7 times 2 times 10, because that's 20, times 200 over 500 times 7 times 2, which is 14. Is 7 times 2. So, okay, we see the 7 and the 2. These cancel out right away. So, because there's a 7 and 2 on the top, 7 and 2 on the bottom. So then we have 10 times 200. Okay, so 200 over 500, that's obviously 2/5. 10 times 2/5 is equal to 4, which is choice A. So notice that I didn't even have to use a calculator to do this because I knew how to factor. Definitely something you want to know for the SAT. Problem 11, page 494. John can peel 72 potatoes per hour. I'm not really sure that I can peel that many, but anyway. At this rate, to the nearest whole number, how many potatoes can he peel in 72 minutes? Well, we want to set up the dimensional analysis, that is the ratios. We have 72 potatoes per hour times 1 hour and 60 minutes. Notice that the hour on the bottom and the hour on top cancel out. So you end up with 72 minutes, or time, multiplying it by 72 minutes, so these minutes cancel out here because there's minutes on the top, minutes on the bottom. So you end up with 6 potatoes times 12, because 6 times 12 is 72, and 60 minutes, which is, 60, 5 times 12. So then, okay, there's a 12 on the bottom, 12 on the top. Those cancel out. So you end up with 6 over 5 potatoes times 72. And if we use our calculator here, we can just go 6 divided by 5 times 72 is 86.4. Since that's less than 0.5, then we round down, so it becomes 86. And so it's 86 when rounded to the nearest whole number. Problem 12. Here we go. Ba-ba-da. Introducing problem 12, page 494. If 3a equals 2b and 3b equals 5c, what is the ratio of a to c? So you want to solve the equation so you have a ratio of a to b and of b to c. We find that a is equal to 2 to 3, or a to b is equal to 2 to 3, I should say. So we're dividing a by b, and then we have to divide 2 by 3. And b over c is equal to 5 over 3, same thing. b over c, we divide 5 by 3. So you can either multiply 2/3, 2 over 3 times 5 over 3 and get 10 over 9, which is the right answer. Or you can find the lowest common multiple of 3 and 5, which is 15, and then you take 2/3, multiply by 5 over 5 to get a over b equals 10 over 15. b over c is 5/3 times 3 over 3, so that's 15 over 9. So then the ratio of a to b to c becomes 10 to 15 to 9, and we can just get rid of the b in the middle, and then you're just going to get 10 over 9 when you multiply 10 15 times 15 over 9 to get 10 over 9. Notice that the 15 disappears. Either way, you can get that. Hopefully you understood that. If you don't, you can contact me if you have any questions. All right, this is problem 13, page 494. If 3x minus 1 over 25 equals x plus 5 over 11, what's the value of x? It's an easy solution. You want to cross multiply. 11 times 3x minus 1 equals 25 times x plus 5. So 33x minus 11 is equal to 25x plus 125. So once we multiplied that out, we can just combine like terms, and we quickly see that when we add 11 to each side and subtract 25x from each side, you end up with 8x equals 136. X is equal to 136 over 8. Now you can solve this without even using a calculator. You can go, all right, well I know 130 is 2 times 65, so 6 is 2 times 3. Oh, okay, so that's 2 times 65 plus 3, so that's going to be 68 times 2. 8 is equal to 4 times 2. So then you have 34 times 2 over 2 times 2. So we just get rid of those two 2's, the one on the top and the one on the bottom. Then you have 34 over 2, which is equal to 17. So that's a neat way if you know to do it. If you know how to factor, you don't need to get your calculator out. And of course, if you're on a non-calculator section on the SAT, you're going to have to be able to do this by factoring without a calculator. Okay. Problem 14, page 494. Here's our profit guy. All right, we have 3 associates who agreed to split the profit of an investment in the ratio of 2 to 5 to 8. If the profit was $3,000, what is the difference between the largest share and the smallest? Well, what you do here is you write x after each number and replace the colon with plus. So we're going to go 2x plus 5x plus 8x plus 15 equals 15x. Sorry, 2x plus 5x plus 8x equals 15x, which is equal to 3,000. And so x is the amount of a part of the profit, or a share if you like it. Basically, I don't mean the 2 to 5 to 8 share, just one part. So 2x, 5x, 8x. The x is going to be $200. So the largest share is 8x, which is $1,600, because 8 times 200, and the smallest is 2x, which is 2 times 200, which is 400. The difference is $1,200. So you grid in 1,200. And problem 15. If y is inversely proportional to x and y equals 8 when x equals 4, what is the value of y when x equals 5? So inversely proportional means that as y gets bigger, x gets proportionately smaller. So where xy equals k, well, so xy is equal to k, which is a constant, and that can be expressed as x equals k divided by y, or y is equal to k divided by x. Since 8 times 4 equals k here, k is equal to 32. Why? Because y is equal to 8, x is equal to 4, so then you just multiply them to get 32. So y is equal to 32 over 5, because k is 32, over x, which is 5, when x equals 5. So you're going to grid in 32 over 5, or 6.4 if you really want to do the extra math. Since you can put in 32 over 5, I wouldn't bother doing this, but hey, you can. And just a little joke about inverse proportionality. For example, your level of skill is probably inversely proportional to the amount that you brag about something. I don't mean necessarily you, but y'all know somebody who basically likes to brag a lot about how great they are at something, and they probably actually suck. So the more skillful someone is at something, the less they brag. I mean, the best guitar player I know says, yeah, I'm okay at it. So that's the kind of thing you do. Or great scientists like Einstein and things like that. They've all said things like, the more I know how little I know compared to how much there is to know. So things like that, Or basically, the likelihood of you dropping if you have a cheap rug, you're probably likely to never ruin it, but if you have a really expensive white rug, that's going to be the one that you spill orange soda onto. Okay, so it's basically the likelihood that you'll ruin the rug by spilling something on it is directly proportional, which we'll talk about in a minute, to the expense of the rug, or it's inversely proportional to the cheapness of the rug. If it's a rug you got for free, I guarantee you'll never spill anything on it. Ha 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 ha. Okay. And on that note, let's talk a little bit about proportions. Directly proportional means as x increases, so does y. So you end up probably with a linear graph like this, where y equals k times x, where k is a constant. So therefore, y over x is equal to k, which can be also be expressed as y equals kx. So, for example, that old rap song, Mo Money, Mo Problems, you could also express it as the relationship between money and problems is directly proportional. As money increases, you can see, if this is money here on the x-axis, then problems also increase. You have people always asking you for money and thinking, oh, you should pay for this, you can afford it. So, mo money means mo problems. That's directly proportional. Basically, if y increases when x increases, it is directly proportional. So just remember that. Mo money, mo problems. All right, I hope you enjoyed this. And for the best results, please, if you haven't, get a copy of the Barron's SAT 30th edition or even the 29th or the 28th edition. This video covered pages 492 through 493 in the 30th edition of Barron's SAT, either the Premium SAT Study Guide, which I have, or just the normal 30th edition of Barron's SAT. The page numbers are the same in the 29th edition, and they're identical or close enough in the 28th and previous editions. You shouldn't use an edition older than Barron's new SAT, which I believe is the 28th edition from 2016 in any event. Not everything in the book is in these questions. Do read the book, that's why I'm telling you to do it. The older editions of this book can be had cheaply, if not for free, from used booksellers, kids who've already taken the test in public libraries. You can go on Craigslist, you can go on FreeCycle, you can go on Rooster, whatever. And if you plan to use a library copy or a new edition, I suggest you start early. There's no worse feeling than needing a library book that someone else has checked out or trying to buy a review book that's sold out. And come on, if you start studying 2-3 days before the test or a week before the test, you're not really going to get all the review time that you really need. Start early. Did you find this video useful? Please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? It's simple. YouTube doesn't let me share any ad revenue unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. I'm getting up there. I've got about, 762, something like that, subscribers right now, but still not 1,000 subscribers. And for the same reasons, you are not only welcome, but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos. I reserve the right to delete comments from and block those who specialize in destructive criticism, trolls, or things that are off topics, spammers, disturbed people. If you want to contact me, you can always call me or text me on my cell phone, 415-623-4251. You can email me at john@johnlinneball.com. My mailing address is 1859 Powell Street, number 109, San Francisco, California, 94133. And thank you for watching. And there's even more contact information if you'd like it. You can contact me on Facebook. You can come to my Facebook business page at www.facebook.com/Linneball Tutoring, all one word. Instagram, you can go to www.instagram.com/john.linneball.tutoring. My phone number at my home office is 415-986-7355. My email, again, is john@johnlinneball.com. My website is www.johnlinneball.com, or you can go to johnlinneballtutoring.com. They take you to the same website. And I have a locals.com site at testpreparation.locals.com. Please consider joining that. It's one way to help me help you. All right, that's it. I hope you enjoyed it. Have a good day.